Hi, everyone. Yeah, so I'm Michael Staib. I'm a member of the technical steering committee of GraphQL. So essentially, you could say the organization that is managing the spec process and writing the spec. I'm also the co-founder of Chili Cream. So we're building GraphQL tooling mainly in the .NET stack, but also for the wider stack, like our GraphQL IDE. So I want to talk to you about building modern applications with modern GraphQL, or let's say future GraphQL, because that's interesting stuff you don't learn in a lot of other talks, is what's coming next for GraphQL. So where are we heading with that? It's good that Antoine already asked if there are people who don't know GraphQL, so I embedded a 3-minute introduction to GraphQL in this. So not to bore everyone who knows GraphQL, but to get all on board who maybe have no idea about GraphQL. So actually, GraphQL was developed by Facebook, for people who don't know it. And it was developed to cater to the mobile-first, cloud-first need that they had back then. So it was mainly developed for native mobile applications. And the first GraphQL server actually was written in Hack. So it was essentially a PHP server. So many people mistakenly think it's a JavaScript thing. And it was created in JavaScript and is mainly made for websites. That's not the thing. It's super good for websites, and today most applications are websites, but the heritage where it comes from was native mobile applications. First GraphQL client was written in Java. Okay, so this is, you could say, the hello world of GraphQL. No, it's not. It's a GraphQL query. That's something I can send to my GraphQL server. And in this GraphQL query, I'm asking for the currently signed in user, and from that user, I want the name. And if I send that to my GraphQL server, I get a response that closely aligns my request. And that's key to GraphQL. And that was one of the main features that we're going after, that essentially your client application, your client component, can ask for exactly the data that you need in that case. And you don't get all the other data that you don't need. And also you don't have to do consecutive calls, so having more requests to the server, just to resolve an ID that you got in a previous call. So that is the main concept. As our use cases change and we need more or less data, we can just change our request, create a new request to get that data. In this case, I'm also getting from my user the image, and from the image a couple of properties here, right? And as we might at this point expect, if I send that to my GraphQL server, I get exactly a response in the shape that I asked for. In this case, I get the additional image data. But if we look at that, we can already see that GraphQL is not about sparse fields. It's actually about trees of data. And that is great for things like relations, where I not only want the user, but maybe also the friends of the user. And we might expect I get a response that closely aligns my request here. There's another concept I want to introduce you to, and that is called fragments. And when Facebook started developing GraphQL, they really thought GraphQL up from the front-end perspective. So they wanted to empower front-end developers to build really awesome new applications. So a fragment is our primitive of composition in GraphQL, and it allows us in the front end to express the data contract of our component. You could say that is our data component. And this allows us to co-locate the data requirement, the data need of the component with our component code itself. Let me give you an example. This, for instance, is a piece of Relay code. Relay is Facebook's GraphQL client. And you can see that, can I point? No. You can see up there where the keyword fragment is, that this is my data contract for this component. And further down here, we can see that is my React component code to render the component. So in this case, I'm rendering here a carousel, and I'm using data that I have in my fragment here, the node ID in this case. And then I'm pushing another fragment that I have up here down to the component. Okay. This just to get you up to where I want to go, because I want to talk about modern applications. So for this, I built a little demo application, and it's about cryptocurrencies. I know that I don't have the best outlook at the moment, but you don't build a new application every day. Okay, let me get that refreshed here. So my Lambda wakes up. Okay, so let's say this is my modern application. What do I think of a modern application, or what do I think is a modern application? A modern application for me. A modern application for me is reactive. It has real-time data embedded. It feels alive to the user. You can see all the numbers are changing as we get new data. And don't sell your cryptocurrency. These prices are not real. So it might be a lot lower. But anyway, so it's reactive. And also, we don't have a lot of data calls. You can see I refreshed this application, and there's just one GraphQL call. And if I, for instance, drill here into the Bitcoin, it's just another call. And see how fluent it works. This application is actually hosted in the US, but it's still really fast and fluid here. And anything I do in this application will just result in one more data call, because I craft these GraphQL calls, and that means I can ask for exactly the information I need. And I don't have to, like with REST, do a couple or a couple hundred REST calls to just aggregate the data on the client side. We let the server do that. Okay, let's go back to the slides a bit and talk about how we can optimize that. Because so far, GraphQL was about reducing network calls. There are other concepts to it, but from what I told you so far, it's about reducing network calls. But actually, when we talk about future GraphQL, or where we are going with the GraphQL spec, we want to empower the user even more. Not just to ask for the data, but to minimize the time to important data. Essentially empower you to, in your GraphQL query, tell us what's important to you and what you need first. And that's a key aspect of GraphQL, that we want to empower the consumer of our APIs. Let me give you an example. Let me go back here. And this is Banana Cake Pop, our GraphQL IDE. And the best feature, by the way, is that we can take the, no matter, okay. Okay, and let me just grab another document here. I already prepared that. And that is the call that I'm using essentially at the moment in my GraphQL client that I have there. And in this case, you can see it's a lot slower than in my GraphQL client, because my GraphQL client, the UI I showed you, was already optimized with the new feature I show you now. So Lee Byron actually presented that feature 6 years ago and told us this is the future, how they want to go in Facebook. And it took us just over 6 years to figure out how to implement it in the GraphQL spec group. But if we go to our client application maybe, you can see that when we do the first call here, we have a lot of data. But I don't need all the data because, for instance, I can slide here to the side and have graphs for other cryptocurrencies. But actually, when I initially load my data here, I don't need that data. I want to see the Bitcoin maybe, and until the user realizes that he can swipe to the side, there is maybe a half a millisecond gone already. So what we want to allow the user is to tell us about that. And we can do that by using the stream directive now here in GraphQL and tell us that we actually want the first cryptocurrency immediately, and then the server can stream us the rest. And then you can see the first pieces of data are now there in 300 milliseconds instead of 900 milliseconds. And that is because we are streaming the data. And let me show you that. We now get the first patch of data down here immediately with all the points for our chart here. And then we get the other cryptocurrencies where you can swipe to the side, right? And that is the same HTTP post call, we just stream it and essentially use chunked encoding to make that possible. So it works over HTTP 1.1, and that's always important for companies like Facebook that want to support as many users as possible. But we can go further here. For instance, I know actually this is the expensive data here. This is what costs us the most. And we can introduce here something that is an inline fragment. And then we can say defer this part. So we essentially deprioritize that. And if we run that again, we actually get more parts, and the request becomes faster even, because now we are streaming first just the head data of our cryptocurrency here. You can see here the Bitcoin, it's just this little piece with the price. So immediately you get the price information. Then it goes on streaming. At some point you get the expensive data that we get from a downstream REST service behind this GraphQL API. So these are the new capabilities that will revolutionize how you develop actually GraphQL applications in the future. Hopefully next spec version. But let's go back to our example. And this was the example I showed you with the fragment in the beginning. And now users can just put a stream directive here. And there's a problem actually, because if you do that without understanding the concept, and this is why it takes so long to develop such a feature, let's do that. Maybe look at the fragmentized version of this query here, and you see it has essentially 20 parts here, but now I just went in and said, okay, I'm further optimizing this thing, and I'm putting a stream down here, and then we just rerun it. And suddenly you wasted your server performance, and you could essentially kill your server. Because now we, by accident, created over 3,000 patches. That's the best way to DOS your server. So early implementers of defer and stream, you should rework your servers. Okay, so in the spec group, we discussed that. First, with great power comes great responsibility, but no, we don't want to leave it like that. We want to actually solve these issues. And what the next spec version, and we are already implementing that for our implementation, Hot Chocolate, is that essentially a server does something like a complexity analysis, a statically complexity analysis of your query graph, and would merge certain differs, because sometimes you just do the defer to tell us, okay, I don't want it that prioritized. I want to deprioritize this section. But often we can merge them. It doesn't matter that you get the exact differs back. Another thing is that we can estimate how much patches these the differs and streams you apply to your queries really yield, and then we could just drop them. We just kick them out. But there is a problem to that. And now we have to talk a bit about fragment modularity, because fragments are our data contracts or our data components. And if we just drop things, then we have a problem. Let me explain that a bit to you. So GraphQL is not about just reducing data calls, it's also about minimizing network responses. And if we look at this fragment structure here, for instance, in the upper fragment, I'm asking for name and symbol. In the lower level fragment, I'm asking for symbol and price. So I have one field overlap. So what GraphQL servers actually do when they look at these queries is they get rid of all the fragments. Because for the server execution, we don't care about fragments. It's a client thing. It's for you to tell us what components you have, but the first thing we do is defragmentize. And that is super efficient, but it leads the client developers actually to a couple of issues. And that is around figuring out what components are fulfilled. So when is my component fulfilled? And if you think about things like React Suspense, for instance, where you organize the rendering of your component with the arrival of the data. So essentially, you just want to render a component once the data for this component arrived. And this has a super nice effect for fluent or modern applications where everything feels instantaneous. But when we drop the fragments, we essentially, you don't know in which batch these fragments are. So we used to use this label here as a crutch, I would say, to have that. But this is problematic, because when we drop this crutch, you cannot figure it out. So what we want to do is reason about fragments in isolation. So if we have some pseudocode here, we want to essentially be able to await certain aspects of our response, maybe await the price details, and then when they are available, do something with them. Or maybe have an API like this where I could check if the price already there. If yes, then I render it. And there are a couple of solutions we talked through. Not all of them are successful and will make it in the spec. But one of them was like having metadata helping with that. Like telling us that there is something in there. For instance, this is fulfilled metadata here, which tells us if a certain fragment is really fulfilled. So we could look into the data, but it would really bloat our data. Another aspect we talked about was using a new response shape and aliased fragments, essentially. We could here use this details alias, and then the response would shift a bit. But with such an approach, we would deduplicate a lot of data, and then our goal of minimizing network responses would be negated. So we sat down again in the spec group, and now we are essentially embedding this in more transport data. So we will have a new pending section here. And only data that is pending or announced as pending was deferred. And with that, our dilemma of figuring out when a piece of data arrives at our client is really solved. Okay, so this is then an incremental part that comes after it was pending. And then you essentially merge these data on the client together. So as an application developer, don't worry about it. Libraries like Relay or Apollo or Urkel or whatever will handle that for you, and it's transparent. I'm just talking here about the difficulties getting such a feature in. Okay, let's change gears here, and the last thing I want to introduce today as a concept is client-controlled nullability, and that's about getting you more power even on the client side than you have now with this prioritization. Because client-controlled nullability, or if we look at the characteristics that we want to have in a modern application, is faster iteration speed between front end and back end, strong contracts between front end and back end, and also things like static typing. And if you look at most GraphQL APIs, actually what we do is most fields in our graphs are nullable. And why is that? Because there's a concept called non-null propagation. So what is non-null propagation? So if we have a query like this, where we ask for two things separately, me and assets, and price, for instance, is non-nullable, or all fields are non-nullable, and something happens in price that yields an error, then what we get back is actually just errors, because the non-null propagation will erase the whole result set. And that's because we always want to ensure that you only get valid results. So if the server violates a contract by having an error in a field, we delete it until we get to a null field or nullable field. So the important aspect here is that we in most APIs would then design price to be nullable because there could be an error. And that is really annoying for client developers. So the client-controlled nullability now introduces a new concept about non-null boundaries or error boundaries to GraphQL, and gives you the power to tell the query what is nullable and not. So you can set your expectations. And let me show you that, because we already have implemented that. And in this we have a query here to, again, get the assets. You can see that. And there is a white paper that is always non-nullable here. So we always have data, except in one case. But my client component maybe is dependent on that. The white paper is there. So I say this is non-nullable for me. You can see the GraphQL IDE hasn't caught up yet, but the server will understand that. So if I send that to my GraphQL server here, I get an error because I violated a non-nullability concept, and now this error will bubble up. And that is where I now can use my non-null boundary powers and say, actually, we want to isolate that and null out the items where we have errors. This is my error boundary here. And now I get all the list, but the item that violated our contract is just nulled out. And I can filter that out on my client component. Again, client tools will help you with that. And then all the data that you get aligns or abides to the non-nullability concepts that you defined in your query. And I have to give credits for this feature was introduced by the Yelp developer engineers. So thanks for that. And let me get to the conclusion here, and then you can ask questions. There are, by the way, other proposals in the GraphQL spec that also will fundamentally shift how you build applications in future with GraphQL, like struct metadata. Metadata is a concept where you essentially can use introspection to get more insights into what directives are annotated on your graphs and other metadata. There's one-off for input polymorphism. It's almost done. And there's a new specified by and feature flags that are probably coming. So why I did this talk is actually because when you look at GraphQL, how much it has developed since 2016, it feels like nothing has happened, or it didn't evolve a lot since 2016. Essentially, we are using the same concepts, and these concepts are great. But actually, we are working on you could say, a revolution in GraphQL, which will enable complete new ways to build applications. So there's a lot going on, And sometimes it's difficult to understand why it takes so long to develop these features. And the case where I showed you how you essentially can DOS your server with defer if it's not implemented right is the case why it takes so long. We have to figure out ways to implement these features in a safe way. So through a lot of incremental changes, GraphQL is evolving in a fundamental way. So the GraphQL of tomorrow will give you so much more power over applications. And I hope you got the idea from the little application that I built, how fluent they can be. So thank you. And if you want to follow me, there are my details. And with that, I'm open for questions.